Hey guys, Mr. T here. This is another video. This one's on quadratic functions. So previously, in your previous topic, we've been looking at functions just in general, and seeing how slight modifications to them, to the function itself or the variable of the function, so within the brackets like that, result in three different transformations, and they were translation, moving up and down, left and right, compression and expansion, so squeezing or stretching towards the different axes, and reflection. So the idea of quadratic functions are they're simply functions in the form f of x is equal to ax squared plus bx plus c. So that may sound familiar when we were doing quadratic equations, which were ax squared plus bx plus c is equal to 0, or a number, and we solved those. So we're bringing that back into it. Why? Because many real-life phenomena involve variables related to each other using a quadratic function. For example, let's say you found the function of the height h of a stone thrown in the air after a certain time t. This turns out to be a quadratic, because the path of a stone is going to be a parabola, right? So h, the height over a given time, is going to be negative 5t squared plus 30t plus 2. So that's not the equation or the function of the height of a stone in general. That's for this particular stone being thrown. But that's just an example of how real-life phenomena could be represented by a quadratic function. Also here, the area A of a rectangular garden bed that's got a width of w, so that can change, but the only thing that doesn't change is that it must use 40 meters of fence. So the area, given a certain width, is going to be negative 2 times by the width squared plus 40 times by the width. So that's another example of a real-life phenomena that may use a quadratic function to relate variables. So, how is that going to be relevant to our topic? Well, the principles of substitution and solving quadratic equations, we can use those for problem solving in questions that involve quadratic functions. So we might want to solve a problem that involves a function like this. We can use substitution, just plugging in numbers given a certain variable, or our techniques of solving quadratic equations, which we did in the last topic, to solve these problems. So let's get into it. Finding y given x. So in function notation way, we would be saying find f of x given that x is a known number k. So you can find the result of a function given the unknown by simply substituting the unknown into the function. Essentially, if the function of x, if you've got f of x and you know what x is, it's given as a certain number k, then we're finding f of k. Essentially, you're plugging in the number k into the function to work out what f of x would be given that number. So, example, f of x is 2x squared plus 4x take 5. So the function that's being applied to x is you're squaring it, timesing it by 2, adding 4 lots of it, and then taking the number 5 from the result. So let's find what f of 0 is going to be. So k in this case will be 0, and find f of 2. So k in this case will be 2. So let's do them one after the other. F of 0 is going to be 2. Replace the x with 0, because we're finding the function of 0 this time, squared, plus 4 times by 0, take 5. 0 squared is 0, times by 2 is 0, plus 4 times 0 is 0, take 5. The function of 0 is going to be negative 5. And that's the first one out of the way. F of 2. So here we know what k is. K is given as 2. So that's what we're plugging into the function. The input into the function is going to be 2 this time. 4 times by 2, take 5. 2 squared is 4, times by 2 is 8, plus 4 times 2 is 8, take 5. 8 plus 8, 16, 11. So that's pretty straightforward. Finding the result of the function, finding f of x given x is a known number. You plug in what that known number is into the function. You essentially are given the input. The next thing that we have to be able to do is a bit harder. So finding x given y. So finding the unknown x given the result of f of k. So doing the reverse process of what we just did above, finding the unknown given the result of the function, f of k is more involved. So essentially what you're doing in this process is, let's say you know that the f of something is 11. You're trying to find the something, or the somethings, because remember, quadratic can have more than one solution. So this process, doing the reverse, uses the techniques we covered in solving quadratic equations, so in the previous topic. So hopefully this is a refresher for you if you're unfamiliar, or if you're not remembering what we did. You might remember the x squared is equal to k rules, the completing the square, perfect squares, factorization, all of that sort of stuff for solving quadratic equations we've done previously. You're going to use them again now. So let's have a look at this. Given f of x is equal to x squared, take 6x plus 8. Find what x is going to be when the result, f of x, is 15, and when the result is negative 1. So what that's saying is, we know the result of f of x is 15, but to get that result, we don't know what the variables inputted into the function were. We're trying to work out what x squared x is in this. So how did we do that previously? Well, the way that we solved quadratic equations is to write things in the form ax squared plus bx plus c is equal to 0. So we need to make this in that form. So I'm going to rewrite it. I'm going to switch sides. It's going to be x squared take 6x plus 8. I'm not actually doing any maths just yet. I just twisted it around. So it's on the left hand side because I like it that way. Now I need to get rid of this plus 15 on the right hand side. What's the opposite of plus 15? Take 15. So x squared takes 6x plus 8, and I'm going to take 15 on both sides to balance it out, and also get rid of the 15 on the right hand side. So x squared takes 6x. 8 take 15 is going to be negative 7 is equal to 15 take 15 is 0. Alright, so we have the form ax squared plus bx plus c is equal to 0, like in this box here. Now we need to use the equation, solving the quadratic equations rule. So always try sum and product first. If you've got the flowchart that I designed, use that. Numbers that I can times together to make negative 7. And go negative 1 times by 7. Is that going to let me add together to make negative 6 over here? No. What about negative 7 times by 1? That's going to let me get negative 7, and negative 7 plus 1 is going to make negative 6. So that lets me do the sum product rule. My a and b are these numbers, negative 7 and 1. So it's going to be x takes 7, x plus 1, factorization, and they equal 0. So then x takes 7 can be 0, or x plus 1 can be 0, therefore x is either 7 or x is negative 1. So if the function of x equals 15, given this function of squaring the input, then taking 6 times it, and then adding the number 8 to the result, x can either be 7 or it can be negative 1 as a solution to this. Alright, so hopefully you can see that that's an application of stuff that we've already done. If you don't remember that, well, look through your book again. So this next one, so we're doing f of x is equal to negative. Now, so what's that saying? It's saying the result of the function is negative 1 is equal to the same function as before. You need to work out what x is to get this result. So, switcheroo, switch it around into the order I like. Is equal to negative 1. So I just put the left hand side on the right hand side on the left hand side on the right. I'm going to make it equal 0, so the opposite of taking 1 is adding 1. Plus 8, add 1, is equal to negative 1, add 1, so add 1 to both sides, x squared takes 6x, plus 8 plus 1 is plus 9, is equal to negative 1 plus 1, 0. Alright, try sum product first. 1 by 9 is not going to get me 6, 3 by 3. Positive 3 by 3 isn't, but negative 3 plus negative 3, negative 3 plus negative 3 will get me negative 6, so that's my A and B, negative 3 and negative 3. You could have also used perfect squares for this, but I always try sum product first. So x take 3, x take 3 equals 0. You'll notice the two factors are the same, so they are x take 3 squared is equal to 0, and this is in the form x squared is equal to k. So the rules determine that x take 3 is going to be 0, x is going to be 3. So this one only has the one solution. For this function to spit out negative 1, the variable x must be positive 3. So hopefully that shows you some of the techniques that we use to solve quadratic equations. Now we're calling them quadratic functions because we've learned about the function terminology and how to write those. And I'll see you in the next video.